So in this video, we're going to set up a tank control system. So as you can see here in this image, we have a tank. And so we're going to be filling this tank. And we want to maintain 65% level. So if you wanted to, you could say that, let's say that this is a 100-gallon tank. And therefore we want to keep it at, say, 65 gallons. But at the bottom of this tank, we are taking out 50 gallons a minute. Now, when I say we're taking out 50 gallons, we're using this. The 50 gallons per minute is a reference or a general amount that we're taking out. But, you know, sometimes we may have more load. Sometimes we may actually be taking out 60 gallons a minute. Sometimes the load may decrease and we're only taking out a few gallons a minute. So this is just kind of a example here. If we know that our output is exactly 50 gallons a minute, then once we get the level to our set point of 65%, then we can have we can set the switch here to maintain at 50 gallons per minute. And so we'll be putting in 50 gallons a minute and we would be taking out 50 gallons a minute, and we would stay right at our desired point of about 65 gallons in the tank. However, if the tank was completely empty and we're going to be taking out 50 gallons a minute, if we started putting in 50 gallons a minute, and we're taking out 50 gallons a minute, we're never going to reach that set point level of 65%. So obviously we're going to have to fill it up faster. So I have this 3-position switch here, and in the 3-position switch, I have one of the settings is going to be the fill setting, which is actually going to max out the pump that's filling the tank. And its maximum is 100 gallons a minute. All right, so if that was the case, then obviously, it would take 1 minute to fill this tank. But, it's just giving us some reference values here for this. So we can, if we switch to the left position of this switch, we can fill it up at a gain or at a speed of 100 gallons per minute. And then if we switch to the maintain value is just going to be what we call open loop control, and we just set the valve to allow 50 gallons a minute to flow. And so we have no control over that. That's all it's going to do. So if we're at our set point of 65 and we put it in maintain and we're taking out 50 gallons a minute, we're putting in 50 gallons a minute, then the tank will fill up, or the tank will maintain that level of 65 gallons because it's putting in 50 gallons a minute and taking out 50 gallons a minute. But the problem with the open loop control is what happens if our output demand starts to increase, and so we actually start taking out 60 gallons a minute or something along those lines. Well, in that case, we're taking out an extra 10 gallons a minute, so within less than 7 minutes, we would be out, our tank would be empty at that point because the open loop control has no control over how fast that's going to flow. So then on the right hand side or the right position of this switch, then we have control. This is going to be closed loop proportional control that we're going to apply. And so if we switch it over to the control, now it's going to provide feedback. It's going to give us the difference between the error of the set point minus the actual level in the tank. And then for control, I've got a second position switch, which we can apply a closed loop gain, and we're just going to set that to some fixed values for closed loop gain then. So let's go ahead and see about programming this. So So I already have RS Logix 5000 opened up. I have my PLC. I'm going to be using the 1769 L23E QB1 Compact Logix controller. All right, and so it has an embedded discrete I/O, and it has an expansion module for relays that I've already connected. But now I'm also going to come in here and add my analog card. And so we're using the fast analog card. And this right here is our card. So I'm going to add that card. And I'm just going to call this analog, give it a name here, analog, and it's in slot 4. So you need to make sure when you're adding modules, you have the slot correct. Now I'm going to come into input configuration. And for my input configuration, I'm going to have my input, which is going to be the sensor monitoring the level. And this is a 4 to 20 sensor, but I'm actually just going to use the 0 to 20 range. And I'm going to apply a 5 Hertz filter on it to try to reduce the noise. And I'm actually going to use percent range control. So the percent here, if you remember, percent actually goes from 0 to 100% theoretically, but because it's an integer value coming in, they actually give us 2 decimal places. So actually 100% would be a value of 10,000 as a decimal binary value within the controller, okay? And then for output, I'm going to basically do the same thing. So I'm going to set it, it's going to be a 0 to 20 milliamp range, and the output is going to be percent. And then we also have to set our output limit, okay? And they actually set it for us here. We want to go from 0 to 10,000, and they actually set the range just slightly higher than that by default. So they set it to 10,500. So we'll leave that in there and create that. So our IO is, I just need to close this, but we can always come back in here and just double check, right? 0 to 20, 5 Hertz percent, and the output is 0 to 20 with the percent range set, and the output limit 0 to 10,000. So now I'm going to come into my tags, and I'm just going to create some tags. And so we want to, and one of the things with the software I find, you really want to kind of rearrange it so that you can see your name and your alias, and you want to use like longer names when applicable. So the first tag I'm going to create is simply a start tag for my start button, so I can use a fill-in loop. And that's going to be local : 1, which is going to be my input, okay? And it's going to be data.0. So that's that bit. Now, one thing you can do here to help save is you can actually, once you get the first one in, you could copy it and then paste it in. Actually, I'm sorry, that was the start bit is bit 1. And then I'm going to do the stop bit, which is bit 0. These are pre-wired on our PLC. So we need to make sure we select those correct. Now we have our 3-position switch. Okay, so we have this 3-position switch. So if you're in the left position, that's going to be bit 2 of this input card. And so you have the fill position of 100%. Okay, so I'm just going to call it fill 100. And again, I can just paste that in because I had that there. So that's going to be for bit 2. And then we have the right position, which is the control position. I'm going to call that control on. So there's no delt. That means that we're just turning the controller on, meaning the closed loop controller on. And that's bit 3. All right. Now the center position at 50 gallons, that's when both of these are off. And so when we program that, we'll have to set up the logic for that and correctly, but I can't add a tag for that really, because it's just the value there. And then we have the gain. So I'm going to have the gain half. Okay, so I'm going to have a half gain, and that's going to be bit 4. And then I'm going to have the gain of 1, which will be bit 5. This is on our second switch, which is a 4-position switch. And then I'm going to have a gain of 2.5. And so that's going to be position 6. And lastly, I'm going to have a gain of 5, which is going to be bit 7 of our input card. Okay, so we've got those set. And I want to enable a red light. Okay, so the red light, and I'm going to go ahead and add a little bit to this description. So when you create tags, the whole purpose of tags is so that you can put descriptive names. So the red light, when the red light is on, then the system is going to be energized, right? So the system is going to be on. All right, now that is local. That's actually my relay card. And so the red light is bit 0 of the relay card. So now I'm going to copy the local 3 output for data, and I'm going to do my other lights. And then I'm going to have a green light. And the green light, I just want the green light to come on if my tank is 25% full. Okay, so if my tank is at 25%, so I'm just going to put that in the tag name so I know exactly what that is. And that's my green light. And then we have an amber light, okay, which I'm going to have on at 50%. And notice I have to type %PCT. You can't use percent signs in tag names. And then I also have a white light, and so I'm going to turn the white light on at 75%. Okay, I don't expect the tank to ever be 100% full, but it's kind of nice just to turn the lights on to give you an indication of how full they are. So that's what those tags are for. So now I need a set point. Okay, so I'm going to have a set point here, and my set point is just a real value. Okay, so if I wanted to put in, say, 65.5 or whatever, so this should just be a real tag or a float. Okay, it doesn't have an alias because it's just a value inside the PLC. It has no connection to the real world. Then I'm going to have my control output, okay? And this is going to be the output that I'm going to send out and that I'm going to calculate. This is my calculate, so I'm going to calculate that value. So that's going to be a real value. And then when we move it in, it's going to lose any decimal points when we actually move it to the output. All right, and then I'm going to have my gain. All right, so I had these gains up here. I guess I named these gains incorrectly. These are the switches. Okay, this is just the gain switch. So I'm going to go ahead and put SW in there to indicate that this is the gain switch setting, and it's not an actual gain. Okay, so I just want to make sure that that's clear. And then I actually are going to have my gain, which is going to be a real value, and we'll use move blocks to move in the different gains based on what the switches are set. All right, and now we have an error. Okay, so our error is going to be the set point minus the gain. And so it's kind of nice over here, you not minus the gain, the set point minus the actual value. Okay, and so what we can do over here is we can use these descriptions also. this will help label us. So our error is going to be the set point minus the actual value. Okay, well, what's the actual value? Well, I'm going to need a tag for that. So I'm going to have the actual. Okay, the actual value or actual percentage. Now the error definitely needs to be a real. The actual value should most likely be a real also. All right, and so then the control out, okay, the control out is going to be the error times the gain. That's my proportional control. That's what I'm feeding back out. So I'm going to take any error that I have between my desired set point and the actual value and feed that back. So again, it's nice in the description field. We can add even more description to our code. All right, so these are my tags. I believe I've got them all set. So now we're ready to come in and actually start creating our ladder logic. So the first thing we're going to do, of course, is just have our seal in. And so I'm just quickly build in my seal in here. And so I'm going to have my stop button, and I'm going to have my start button. And then I'm going to just use the red light bit to indicate that that's energized. And so then that's going to turn on my red light, which enables the system. Okay. So now, if the system is enabled, then I'm going to, okay, so if the system is enabled, then I'm going to have to look at this switch and see whether I'm filling at 100 gallons a minute, 50 gallons a minute, or I'm in control mode, which is where the controller is going to decide how much we're going to put in. All right, so I'm just going to add a rung here. And so if my system is energized and the fill switch is at 100%, okay, fill 100%, then what I'm going to do is I'm basically going to move, where's my move, there it is. Okay, so I'm going to move from the source, which is going to be simply 10,000, because remember 10,000, and the destination then is going to be my actual output. So I guess I forgot a tag. So I could create a tag there, but I'd like to do it over here. So I'm going to create a tag. I'm going to create a tag here for, I have my control output, but I need an actual output, which is going to be my connection to the valve. This is going to be my control to the valve. So that is an output, and it's channel 0 data. Okay, not a bit, but the entire integer. Okay, so my output to valve. Okay, and then I also have the input from the sensor. So I need to put the input from the sensor. Okay, so this is going to be my input. So it's local :4:I for input, channel 0.data. So you see these are both on that analog card, but this has an O for output and this has an I for input. All right, so So we're going to move, we're simply going to force, if this is at fill 100, we're simply turning the valve completely on. So we're just going to move 10,000 out to the destination to the valve. Okay, and we're just going to force that move. Okay. Now I'm going to copy this, but what I'm going to do is now I'm going to go to control. So if we're going to do the control, if the control is on, then I'm going to have to calculate the control. So let me come back to that. Let me just add one other rung here. All right, and so here, what I'm going to say, if I'm not filled and I'm not in control mode, then I'm going to send out 50%, right? So this one here is sending out full, turning the valve completely on. This is turning the valve at 50%. So remember, at 50%, I'd be putting in 50 gallons a minute. And the hope is, or the thought is, if I'm taking out 50 gallons a minute, I'll maintain my set point. So I would turn it to 100% full, get it up to the 65% desired value, flip it over to maintain, and I'm putting in 50 gallons a minute. So if I'm putting in 50 gallons a minute and I'm taking out 50 gallons a minute, it will be maintained at that set point. So this is open loop. I have no actual control happening here. So if I take out less or more, my level in my tank is going to change because I have no control of it. So then we're going to come down to this last one now. And this last one, we're going to control this value. And so we need to do a couple of different things here. The first thing we're going to have to do is we're going to have to move the input or scale. We would actually normally do a compute statement to compute the actual value, which would be in pounds. So in this case, I'm basically doing a move. I'm going to output my input here. So my input from my sensor. Okay. So I'm going to take my input from my sensor and store that in the actual value. So the actual value would be like how many gallons I have here. So the input from the sensor. So the input from the sensor here would be have to be scaled. All right, and so since I'm doing percentage, I would actually simply divide that by 1,000. So the first thing we want to do here is just bring in and scale our input. Then what we're going to do is calculate our control output. Okay, not control on. Sorry, wrong tag. Oops. Forgot what I named it. Control out. Okay. So we're going to calculate control out. Okay. And so the control output, this is that proportional control. So this is going to be our gain times the set point minus the actual value. Okay. So that is really our control. This is really our control block here. This is proportional control. We're going to take the gain times the error. Actually, I created an error tag, but I didn't actually use that because it's just set point minus the actual value. So I guess I don't even really need the error tag. You could have it here separate if you want, but you know, or we can just delete it, and, you know, because I'm not really using it in here, because set point minus actual value is my error calculation. So I don't need to separate that out. I can just multiply it by the gain. And then I need one more of these. All right, now, while we're looking at this, with this software, I have two choices. I could come up here and add a new branch. But when you do that, if you notice here, when you add it that way, it makes it like a sub branch, and that just doesn't look real nice unless it should be a sub program kind of thing. So what I like to do here is when you click right here, do a right click and add branch level, and that'll make it, instead of making a stair step sort of thing happening, it'll make it just the actual value. So now I need to take my control out. All right, and this would be a compute statement. So I need to multiply that times 1,000, 100 times my times the control out. Okay, and the destination then, okay, the destination is going to be the output to the valve. All right, so here I'm bringing in the input and I'm scaling it. So I'm performing scaling. Now, since I'm simply doing percentages here, it makes it pretty simple. Assuming I've got my sensor calibrated to the tank and my output control calibrated to the valve, I'm just outputting 0 to 100%. So if I've done the calibration on the physical valve and the physical sensor, then this makes this scaling very easy. All I'm doing is dividing by 100, because the input from the sensor is an integer, and it's basically multiplied by 100. So if it's 100%, it's 10,000 instead of 100. And, you know, if it's 50%, it would be 5,000. So I'm dividing that out here to get it into actual percent of the tank. And then I'm calculating my control, and then I'm sending the output back. Now, the one thing that I haven't actually done yet is set my control for my different gains. All right. And really, you should do that before your control. Otherwise, if you make the change, it'd be a scan beyond that. Okay. And so I'm going to come up here to number 2 and do a control R and add in a blank input here. And what I'm going to do is just set the gains. Now you could do this with, I've got a 4-position switch, so I have 4 different gains. So I could do it with 4 separate rungs, but since they're all kind of connected, what I could do here is add a branch in here and then do my control on that. So if I have my gain of half, okay, so if my gain half is on, then I'm going to do a move. So I'm going to just take this block and copy it in here. And I'm going to put the move right there. So you see how that slid it over? And now I'm going to move. If this is the case, I'm going to move. My gain is 1/2. So I'm going to move 0.5 into my gain variable. All right. And then, you know, we can copy these. All right. And move a gain of 1 in here. And so this would be a gain of 1. and then we could add the branch or just copy the branch. Okay, and so we're going to have a gain of 2, 5, and a gain of 5, and then put in that values 2.5 and a gain of 5. So what I have again is I put these all on the same. I placed these all on the same. You notice it's not quite happy with that. It's giving me an error over here. So what I do need is I do need a contact value. Okay, so I'm just going to verify my rung and see my error. Rung 3 reference tag is undefined. So I guess I didn't think I needed that. I just oh, my gain 5 here was gain 5. There we go. That's what I was upset about. So all right, so again, let's look at our code. We have our fill-in circuit up top. We have our selector switch to just fill up the tank. We're going to turn on the valve at 100%, and that'll fill up the tank. And then we also have the open loop control. This one here is the open loop control. And it's a 3 position, so it's either position 2 or position 3. And I'm saying here it's not position 2 and it's not position 3. Then I'm going to put it at that maintain value of 50% or 50 gallons a minute. And then I have a rung here, which is just selecting the gains. And then I have my control. So notice this one, I don't even have any control. All it's doing is moving the gain value based on the 4-position selector switch. So I don't really need control of that as far as whether the system's energized or not. If you wanted to, you could put, you know, the system energized bit over here. That's fine. But a lot of times it's just, if you don't really need it, it's better to keep it simple. So if things start breaking, you know why. So here again, this is really my control, my closed loop control. I have my, if my system is energized and my control is turned on, then what I'm going to do here is I'm going to move out the system. Well, I'm bringing in the input, scaling my input. In this case, it's a real easy scaling, but if you had to, you know, go through the scaling process and do any scaling. So this is scaling the input, storing it into an actual value in terms of gallons or percentage. And then I'm calculating my control. This is proportional control. So it's simply gain times the set point minus the actual value. Notice the parentheses, very important there. And then I'm scaling my calculated control output back out to the actual actuator valve of the system. So rung 4 is really my closed loop control here. All right, so now the system is basically ready. All I should have to do is download this and test it. Okay, I'm not actually connected to the PLC network right now, so I can't actually download this. So I hope I don't have any typos in here or something that I missed that was critical. But I did just remember one thing I did miss. I need one more rung. And that rung is if the system is not energized, okay, if the system is not energized, so I'm going to make this examine if open, saying that the system is not energized, then I need to move out to my valve. Okay. My valve should be set at 0 if the system, so I'm going to copy this and put it down here, right? So if the system is not on, I need to be making sure that the valve is off, okay? So that So if the system is not energized, we need to move 0 out to the valve so that the valve is closed. We need to make sure that the valve is closed. All right, so that should be the program there. And so we could just then at that point connect to the PLC, download the program, and run it.